hopefully I'll leave enough time at the end for plenty of questions. So like Tim was saying, we were over at Mark's lab at Falcon Space. Tim had just gone with Mark down to visit Drew, and they'd driven back. I'd gone over there to do some RF stuff on Mark's equipment, and Providence smiled upon us. So we ended up getting the sample the day before I was supposed to leave. So I ended up kicking my flight back a couple of days so we could do some extra time spent with this sample. So let me next here. Oops, there we go. All right. So I'm just going to give you a quick brief outline of what we're going to go through. First, you got to know the history about this thing. The history starts around May to July of 1947. There was a bunch of UFO stuff going on in the U.S. around that time. And then we're going to get to the source for this, the person who supposedly grabbed this off of a crash in July of 1947, who eventually passed it off to his grandson in 1974. And then the source, the grandson, eventually passed it off to Art Bell and Linda Moulton Howe in 1996. And then Linda ended up selling a piece over to the Stars Academy with Tom DeLonge and Hal Puthoff back in 2019. I'm going to go through all of the previous analyses that have been performed on these pieces. There's a lot of them. Linda Moulton Howe has done the majority of the informing the public on this piece for good reason. I mean, she's the owner of the pieces, and she's the one who's been paying out of pocket for all of the science work being done on them. I'm going to correlate it to some other UFO crash debris. We're going to go through some of the debunking of this, as well as some potential validation of this. Then finally, about the halfway mark, we get to the good stuff, which is the picture you see in front of you, our observations, what we saw over at Falcon Space when we were inspecting the sample. After that, what we still want to do to this thing, because this is all late breaking. This was like a week ago that we ended up seeing this, and then I crammed all of this slideshow and presentation in this week to be able to present it to you guys today. So it's a lot in a little bit of time. Then I'm going to start going into some of what other people have speculated the stuff might have been used for. And then we'll go into my personal speculations, which are a little more on the extreme side because I like to take it to the nth degree pretty quick. All right, so May of 1947. I'm not sure if you can all see my cursor, but we got two black dots on this map on the left-hand side. In May of 1947, that second inmost left dot is Horse Springs, New Mexico. That is where there was a UFO crash in May of 1947, sometime. I don't know the exact day. And then the very last day of May of 1947, there was another crash over in Socorro, right smack dab in the middle of this map. Then we get to mid to late June. That's when Kenneth Arnold over near Mount Rainier sees the 9, quote, wedge-shaped discs. Then over at Roswell, that apparently was not a single event. That was over the course of a couple of days. They had 3 different crashes. With this crash in the very center dot, we got this black rectangle called White Sands Missile Range. That's the spot where we think this sample came from. But there was also a crash up in Corona and a crash over in Roswell, all within those couple of days there. The grandfather is the one who said that it was recovered somewhere west of the Sierra Blanca mountain range, which is how we are able to establish that it was the White Sands crash. All right, so starting with the history of this thing. So you got an Army Air Sergeant. This is just prior to the Air Force being created. You got an Army Air Sergeant. He was first on scene at the White Sands crash. He gets there. The thing is still glowing for 3 hours after it crashes. So I'm going to assume that he didn't just reach up on a glowing thing. But at some point during this crash recovery process, he reaches towards the center underside of this disc and peels off a handful or two of the hull and shoves it in his pocket when nobody's looking. He holds on to them until 1974. And at that point, he tells his grandson, as well as a couple of other people, all in one sitting, like, hey, this is what went down. I wrote all of my stuff down in a journal. All of these pieces are, stored in tissue paper in a shoebox in a closet. And I'm getting ready to die. So he dies that same year. The grandson inherits the samples, and including the journal. The grandson, according to the letters that he sent to Art Bell and Linda Moulton Howe, he gave a piece of the debris to a friend of his who was aircrew on a C-130. That C-130 got struck by lightning and crashed in November of 1978. I got links here if you want to follow up on these. I'll share the link to the whole presentation at the end. Anyways, so that scared the crap out of this guy, so he doesn't tell anybody. But this friend was the only person who he had like confided in about this whole thing. And the friend, who happened to be carrying one of these samples, dies in a suspicious lightning-induced plane crash. He was scared good. So he doesn't say anything for 18 years. And then in 1996, in April, he sends Art Bell a letter. In that letter, he says, hey, I got some good stuff. I'm going to send you some good stuff. A little bit later, he sends him a second letter with a package full of what you'll see on the next page, which is a bunch of aluminum samples. The third letter / package is the one that actually contained, quote, Art's parts, these layered materials. And there was 6 samples in that package. I highly recommend that anybody that's really interested in this, follow that link down there at the bottom. It says link for letters. That'll take you to the Earth Files, Linda Moulton Howe's Earth Files page, where she's got scanned copies of all of these 5 letters that the dude sent. There's some really interesting stuff in there. As a teaser, one of the things in there is the guy says that his grandpa, who is that Army Air Sergeant, the grandpa spent like weeks with the one surviving alien from the crash, and apparently the alien said, yeah, sometime around 2025, we're all going to show up and make ourselves known. That's just a good teaser for why y'all should go read these letters. Not that I would put a whole lot of credit in that. I'd put a big old bag of salt with it, but I'm a sucker for whenever you got dates for the aliens showing up. Anyways, so here's the picture on the lower right-hand side of what was in the first package. We got these aluminum little tiny disc punch-outs, as well as square punch-outs. We got one larger aluminum disc, and then we got these weird fin things, these like radiator fin things over here in the lower right-hand side. A lot of people have tried to figure out what's the deal with those radiator fins. Those look a little suspicious. One thing that somebody mentioned was maybe it's being used as photocathodes, you know, a way that you can like get a whole bunch more electron flow going off the edges of these things. It's possible, but unfortunately, Mick West, who I'm not going to say anything, but Mick West, he actually did a pretty decent job on this, I guess. In between these fins here, you can see these grooves that look kind of bent. And that right there, that is a telltale sign that these things were bent at some point. And it appears as though these things came off a radiator of some kind. Mick West claims that it came off of a radiator from some vehicle from 1925. I couldn't find which vehicle exactly it was, but he sounds pretty confident, for whatever that's worth, that this came off a radiator. I can't say one way or another. I hate to say it, but I kind of like the radiator explanation for this, but it still doesn't necessarily preclude it from doing cool stuff. Just because it looks like a radiator thing, it might not have been used as a radiator, it might have been used as a photocathode, or maybe it was being used as a radiator, but still on a craft. I feel like I'm grasping at straws here, but let's just, for the moment, continue to give the benefit of the doubt to this sample until a little bit later. So here's the actual Art's parts. We got these layered samples. Here's the shiny side from the top and the dark side from the bottom. That shiny side on the top is almost pure magnesium. The dark side on the bottom is almost pure bismuth. And then you got this layering throughout where it alternates between bismuth and a magnesium zinc alloy with very small amounts of zinc. It's like 2.4% zinc in all of these bismuth / magnesium zinc layers. You can see over here the sizes of them. The bismuth is really thin. The magnesium zinc is really large. So Linda Moulton Howe has hired over 100 different professionals, scientists and material science, like manufacturing guys, just everybody. She's throwing the kitchen sink at this thing, trying to get as much data about it as she can. So here's from her book, Glimpses of Other Realities, Volume 2, where she shares some of the earliest scanning electron microscope, SEM images, and it's inverted. So these white lines are actually the bismuth, the dark bismuth. And then in between there, you got the magnesium zinc alloys, right? Hal Puthoff has been working on this sample for quite a while, long before the To the Stars Academy. And he's pretty convinced that these things are waveguides. And the reason why is because he observes how, as you look at the waviness of these lines, it appears as though the waviness of the lines is correlated between these different layers, right? As it goes down here, it goes down here, it goes down here, it goes down here, right? He's seeing some kind of thing like that, and it doesn't quite seem like dislocations. It seems intentional, according to Putoff. They also did some X-ray diffraction stuff. They've done a fair bit of isotopic ratio stuff. The XRD and the isotopic kind of leave something to be desired. They were doing it back in the 90s, and they've done more since then. Like I said, it's like 100 different professionals have analyzed it. We got a chance to see some more of those analyses that we can't quite share, but like it's not a whole lot of new stuff in there. So here's the isotopic stuff, and this is a bit saddening. So you got these solid lines here. The solid lines are from the control sample. And what we're looking at is we're looking at the amount of non-terrestrial magnesium to terrestrial magnesium, because the isotope changes, the number of subatomic parts, it changes whether it comes from off Earth or on Earth. So the control sample, you can see just how large these error bars are. And we only have 3 data points for the control sample. And then for the test sample, we only have 2 data points. And over here, this is percentage, so 13.9%, 14%, 14.1%. Well, like the actual range, when you really start getting into the numbers here, anywhere from 13.5 to 14.7%, like that's pretty prosaic, pretty earthbound, right? It'd have to be like 20%, 25%. That's where you really start raising your eyebrows. So if this thing did come from off Earth, they chose to use terrestrial magnesium. It's weird. This does not necessarily support that it came from outer space, but rather terrestrial base. Then over here, we got some more spectroscopic analysis here. Here, they're showing the elements that were involved. Very little amounts of zinc, a lot of amounts of magnesium. And then that was for the shiny side. For the dark side over here, you got a lot of magnesium and some bismuth as well. Bismuth shows up down here as well. From some of the documents I read, it seems like if you did want to get cool physicsy, propulsion-y stuff, you'd probably want to be below 40% bismuth. And I couldn't find any reference that says just what percentage the bismuth to magnesium was in these. So somebody can find that. That'd be pretty cool. Something to observe is that the Betterton-Kroll process is often given as like how these layers were created. The Betterton-Kroll process is how you take molten lead, you pour in a bunch of other stuff, especially bismuth, and that kind of collects all the stuff in a dross, and you scrape that dross off, and that's how you get these layers, is from this lead refinement process. Yes and no. It definitely seems like it's some kind of similar process that was creating this for a lot of reasons I'll get into. But one little weird thing that I haven't been able to quite get a good answer yet is if indeed it was a lead refinement process, you would think we'd find lead, and especially lead oxide. There was no lead oxide found in one of the studies that I can't share. Lead was found, but it was found at like extremely small. We're talking like small parts per millions, like below the threshold that the thing could reasonably detect, like at the margin of error. So like, where's the lead? Here's another cool test they did. They took 90 milligram sample of this thing. They dropped it in just some distilled water, and they watched what happens. Well, they had already observed that the magnesium in this was like ionized magnesium. It was magnesium ions, magnesium 2+, and that it was at, quote, 60 times the concentration of normal. I have no idea what that means. Maybe it was really oxidized. I mean, who knows? Whatever it is that Linda is referring to when she says that the magnesium was at 60 times the concentration of normal magnesium ions, that it seems like it did some weird stuff when you dropped it in water. So drop this thing in water. They let it sit there for 40 days. They take the cellophane off, and this is in one of the videos that I'll link to that Linda shares. They take the little cellophane wrapper off of the beaker that they had this thing in, and they light a lighter, and poof, and they're getting hydrogen off of this thing. All these little bubbles, that's all this hydrogen. And it's leaving these little nucleation sites. It's kind of weird. So I follow up on that with Wikipedia of all places. Now, this sample did not have aluminum in it, so take this with a grain of salt. But magnesium and zinc, you throw them in water, if there's an oxide layer, it's going to really slowly react to the water. So not really sure what this tells us, but somebody that's smarter at material science than me can probably figure something useful out from that. It's an interesting test. All right, so 2019 rolls around and Linda starts getting some flack. So what happened was Hal Puthoff, who'd been working on this sample for like at least a decade or more, I guess, like prior to this, like he'd been a big part of this for a long time. He joins To the Stars Academy. He's gung-ho that this is a terahertz waveguide thing with those small bismuth layers, and he really wants to test with the terahertz. Problem is, with this specific frequency of terahertz radiation, not easy to come by. There are very few places that actually can make that specific wavelength. So he ends up finding out that the Army has these terahertz sources. So respectfully, he comes to Linda and he's like, hey, look, I finally can test my hypothesis, but I know how you feel about giving UFO parts to the military. It means that you're probably not going to get the sample back. It's 50-50 whether or not they'll even tell you the results. What do you want to do here? I mean, we have to test this angle. And so Linda said, let me get back to you. So she goes and thinks about it. She comes back next day. She's like, look, I tell you what, I got 2 samples left. I will give you one of the 2 samples for the cost that I have incurred thus far to do all of this testing that I've done. She's hired a lot of people. She's done a lot of testing. She's built up quite the bill on this pieces of metal that she's holding on to. So for 35 grand, 2019, she sells it to Puthoff, who then put it in with the Army terahertz lasers. And a bunch of people are saying, well, why haven't we heard anything from this? Well, it's the Army. It's To the Stars. I don't know. I don't know why we haven't heard anything, but it's not hard to guess. Either they found something or they didn't find something. And either way, we're not going to probably hear about it. All right. Now we're getting into some better stuff. So there's similar cases where pieces were recovered that had somewhat similar characteristics of this sample. So some of the ufologists in the group might recognize that back in July and August of 1952, there was 2 incidents where the White House was dive bombed for UFOs like crazy. Like it was 60 different UFOs were like dive bombing the White House. It made the news. The 4-star general had to come out and like talk to the press about it. It was a big deal. Well, in one of those 2 incidents, they scrambled an interceptor aircraft. The aircraft chases one of these 2-foot diameter discs, 2 feet in diameter. And he shoots at the thing and he manages to knock off a piece of this thing, glowing piece, about a 1-pound piece of chunk of this 2-foot diameter disc. He knocks off. So he immediately radios in, says, hey, here's my location. Go retrieve the sample. So they go to retrieve the sample. It's glowing for 1 hour after it had hit the ground. Unlike the 1947 saucer samples that we're looking at that supposedly glowed for 3 hours from a much larger craft. Here's where it gets interesting. Apparently, Sarbacher, who is someone that Jeremy Reese has mentioned a time or two, Sarbacher was like this insider DoD scientist guy. Apparently, there's a MUFON case where it's described that he was the one who analyzed this. Supposedly, this sample from the 1952 White House flap had a matrix of magnesium orthosilicate, and that matrix had thousands of, the MUFON case says 10 micron spheres, so I'm going to split different. I'm going to say 10 to 15 micron spheres scattered through it. The MUFON case says that they were spheres of bismuth. I haven't been able to follow up anywhere where it says that Sarbacher said that it was bismuth, other than that one specific MUFON case that somebody wrote up in 2015, and the only reference that they gave to it was this book, Flying Saucer Serious Business. So if anybody else can find where Sarbacher was actually the guy who analyzed this, that would be super helpful. Moving on. All right. So here's a picture of the sample that we had. We're talking about these little tiny micron spheres in a matrix alignment. I'm going to get to it here pretty soon, where these little colored dots, they seem like they have a certain ordering to them that might suggest that they are in some kind of matrix, as well as their sizes. But let's keep going with other similar samples. So Ubatuba, Brazil. Now, I thought I saw some source that said that the Ubatuba thing was a crash that occurred in the 30s that wasn't until 1957 when the samples from that crash actually started getting analyzed. Either way, we'll just stick with 1957. So Ubatuba, it was a craft that like exploded over the water next to a beach, and some fishermen saw some pieces fly onto the beach that didn't hit the water. He collected them. He hands them off to some scientist, academic guy. The academic guy ends up channeling them up the food chain to get tested. There's actually been a couple of really good white papers written on the Ubatuba stuff. That one, though, was like almost pure magnesium. And its magnesium ratios seemed, once again, fairly terrestrial. So this graph in the lower right-hand side, this green dot here, that's nominal values for magnesium isotopes. The letter C down here in the corner, this is the Ubatuba sample test. The rest of these are all like Dow chemical and, you know, other materials like control samples. So the test sample is this C right down here. So if anything, it's more terrestrial than the stuff that is being used by as the control samples. So that's kind of weird. Now, another one thing to mention about this, you can follow up with these links for the ResearchGate paper on it. But the Condon Committee back in the 60s, which a fair number of people recognize the Condon Committee was kind of like Arrow. They're not necessarily perfectly genuine in their efforts. The person in this paper is suggesting that there might have been a major error in the Condon experiment that was establishing the magnesium ratios of these, that they misrepresented the mass of the sample. So instead of being 14.3%, which is way up here, it could have actually been as high as 23.1%. So the jury is still out. There's still a hope that the Ubatuba could actually have been like extraterrestrial, because that's enough to raise an eyebrow. But I don't know if, I think Gary Nolan might have tested the Ubatuba. Don't quote me on that. Anyways, there was 37 trace elements detected in this, and these trace elements, these are the things that really convinced me that we're looking at some kind of refining process. All right, first I'm going to compare side by side, though, the Ubatuba on the left and the ARTS parts on the right. And you can look at these percentages that we're looking at. ARTS parts is like 14 to 14.1. This one down here from the Ubatuba is like 13.7, 13.75. Not up in the 20s, unless we say the Condon was mistaken, which they very well might have been. Oh, there we go. All right, trace elements. So when you look through the Betterton-Kroll process, there's a lot of different recipes for it. One of the recipes says you can use strontium to do the process. One of the weird things, though, is that I want to say the isotope for strontium they use is this one, strontium-88, which has, you know, really high abundance level in the crust, right? But down here, we see that strontium-84 has a very low abundance level, and that in this sample, the amount of strontium-84 was 32% above what it is in the crust. Well, that's kind of weird. That's not just Betterton-Kroll. That's leaving room for the weird. Then over here, now we're going back to less weird, more Betterton-Kroll. So in Betterton-Kroll, you use calcium, you use strontium, you use barium, and of course, you'll find lead in it. Well, for these first three, calcium, strontium, barium, there's a fairly decent high parts per million of those three, which that's what you would expect from a refinement process to find those. But once again, the lead is really pure. There's very little lead. We got 7 to 15 parts per million for what's going on here. I don't know what's going on there. I'm gonna say that it's very possible that I don't understand the Betterton-Kroll process well enough to speak intelligently on it. Maybe the Betterton-Kroll, you are able to get super pure lead-free and lead oxide-free stuff, but one of the reports on ARTS parts that I read said that the lack of lead oxide was one of the weirdnesses of it. All right, so getting to our sample. Now we're getting into the goodies. So here's a picture of it on a penny. A lot of people have been asking, what's this white stuff? That white stuff is the glue from the previous owner who was putting it on the tip of like a rod to do testing on it. So yeah, it's not like quartz crystal or nothing else, just glue. We don't want to try to peel it off because it's so small. We'll probably snap the thing in half if we try to do that. And you can see it's very, very small. How we got this, the worst answer in all of ufology, we can't tell you. So the donor for this thing has requested not to be revealed, and we respect that, and we respect this person. However, this person was able to give chain of custody for the thing, which is nice. So we're able to have multiple layers of validation that this thing is indeed what is claimed. Also, additional scientific reports for arts parts was provided. Once again, non-disclosable. And for those who are saying that, how much did you pay? We didn't pay for the sample. Sample was freely given. All right, so here's some interesting stuff. So it was Tim, Mark, and myself who did the majority of the inspection on this thing. Tim took a look at this thing. Within a few minutes, he's saying, hey, it looks like it's got hexagons on it. And boy, did that pique my interest. So I start looking for the 120-degree angles that are like obviously apparent in hexagons, and I'm just finding them all over the place. They're all over the place on the shiny side here. And I got these green lines here that you may or may not be able to see that kind of indicate some of these 120-degree angles all over the place. You flip it over, so instead of the bubbled side, it's the like concave side here, the bismuth side, and you can kind of see this purple is because we had UV testing. This was a UV light, and I'm just using this picture because it makes the shadows easier to see. You can kind of see we got these offset hexagonal cells here, right? And some of these hexagonal cells seem like they're somewhat different sizes. Yeah, also there's another image we can't share of the larger sample that seems like it has a big old hexagon like cut on the thing. Yeah, so hexagons are a thing. The thing that I spent the majority of my 16 hours worth of looking at this thing was these little colored spheres that crop up all over the place. And I have a video that I'm going to play for you here in just a second after I show you a couple more pictures. So Mark and Tim have released some really high-res photos, and even better photos are coming. Remember, this is all super late breaking. This is like within the last week. So be assured we're going to have a lot better quality stuff coming out here in the very near-term future as we get better and better equipment to be able to analyze this and upload, 8K photos and like 20,000x microscope photos, and all the goody stuff is coming. So for those who might be a little impatient, tough luck. Just wait a little bit. We're going to have a lot better stuff as we have more time to do stuff with the sample. Anyways, I got some of these orange arrows pointing at some of these colored dots. I got some more pictures. I'm going to show you these colored dots. I took this blurry grainy one just because it kind of blooms some of these colors that you can see. I got another one here. I drew these little red lines here so you can kind of see some of these dots. Once again, I apologize that these are so blurry. I got some less blurry ones coming up. Here's some different lighting. In the very near field here, you can kind of see some of these colors that I'm observing. You got kind of like this blue and this copper green, this yellow and this like pinkish color, some white colors. Got all these different colors all over the place. And what's really cool is right here, you kind of see like this circle of colors with a single color in the center. Another little one over there. So and then you got other ones where the colors are all running along a ridge line. I don't know. I think the colors are weird. I think they might indicate either something extremely prosaic or something extraordinarily revolutionary. It's hard to say yet until we do X-ray diffraction. Here's a zoomed in of that same one so that you can kind of see these colors again. All right, so here's the video. I'm going to try to play this video. It's like 4 minutes long. I'm going to play it a little bit fast forwarded, hopefully, if it will let me. Oh, no, it's not letting me. Uno momento, and I will get this thing playing. Okay, well, maybe I'll play the video at the end after I'm done with it. Basically, this video is a 4-minute video, which I have links in the presentation I'm going to share anyways. So people can go back
sorry,
and watch
Jared,
it
let me, you know what? Here, let me add it to stage. Let me remove yours, and I will add this one. There we go.
There we go. So as we're watching this thing, it's a 4-minute long video, so a little bit long-winded here, but I just want you guys to like try to see some of the stuff that I was seeing. Look for all those colored little dots. You're probably going to want to go back through and watch this again a couple of times, and do some frame by frame to be able to see where these dots show up and where they disappear. They become very apparent, especially when the light turns right onto the very edge, and so you get the best shadows. Warning, this is going to flash the screen bright white here a couple of times, so epilepsy warning. Just the nature of doing business with a flashlight on a 2 millimeter sized thing. Slightly zoomed in. You can see that bright turquoise one in the largest hexagonal divot. Some also bright pink ones. There's some bright yellow ones. Some of them are much brighter than others. I don't know what caused them to be bright or not bright. There was also some interesting things where as I removed the light source altogether for just a second, they remain lit. So like that's kind of weird. We did some green laser tests as well. And from some of the green laser tests, like the green laser, as it shines underneath the thing, like it's somewhat translucent. Like you can see the green laser peeking through the sample from beneath. That was kind of interesting. So some of these bismuth colored balls, some folks have said, well, that just happens when bismuth gets hot. It can bead up like that. That's a pretty decent prosaic explanation. And I would give it a lot more credit if we had like bunches of the same colors, but instead it seems like you don't see a whole lot of the same colors next to each other. And you see some of these circles and lines of these colors. And then it's not in this video, but when I looked at the thing edge on, you could see the colors kind of go on diagonally. Now you could see the iridescent bismuth, you know, gasoline on water or soap bubble type thing. Like you could see that on the edge on as well. But in addition to that, you could follow a line of these beads of colors and you could watch it go at an angle across the thing through the layers. Yeah, these beads are super interesting to me. That once again, they might be totally prosaic. We don't know yet. Not until we do the X-ray diffraction, which hopefully will be happening somewhat soon. I do want to reiterate that this is on the underside layer of the inner layer of the craft. So the outer layer of the craft was aluminum with some atomically placed iridium, supposedly. And then the inner layer was this layered magnesium zinc bismuth layer. So yeah, I don't know. There might be melts. You might be able to see a little bit of melt on this thing, on the outermost edges of this thing. But yeah. All right, Tim, I think the video is done. If you can go back.
Yeah, sorry, I put the slideshow back up, but it looks like it went back to the first slide. Can you tell me which one you were on, or did you run through them all?
Oh, let me stop sharing and I'll share again. Maybe that'll work.
Oh, maybe you took it down. Okay.
Here we go. Yeah, I took it down, put it back up.
Nah, no worries, man. Okay.
All right, there we go.
So this is your video. Okay.
Yep. So now, there we go.
Oh, perfect. Thank you, sir.
All right. So we have some other testing we did. We didn't just shine a light at it for 16 hours. I put it on the scale. I put some calipers on it. The sample that we got weighs about 7 milligrams, give or take a half a milligram. There's a little bit of airflow on the super sensitive scale, so call it 7 milligrams. The calipers, the long end here is about 4 millimeters. The shorter end here at the widest mark is about 2.5 millimeters. We did some magnetic tests on it. I ran a magnet around this thing to see if it would move because, hey, bismuth, diamagnetic, maybe it'll respond somehow. It didn't respond to the magnet. I put a Geiger counter on the thing, didn't get any radiation. Put a tri-field next to the thing. I didn't get anything from the tri-field. Not to say that it wasn't producing EM, but just not EM in the range that tri-field was able to measure. And we did multiple wavelengths of light. We had UV light, we had green laser, and we had a LED flashlight. And LED flashlights have red, green, blue LEDs in them. So, multiple wavelengths going on. So here's some more non-destructive testing that we want to do to it. We don't really want to do any destructive testing on it because it's so small and we can't really separate enough from the sample to do decent destructive tests on it. But the very first one, the highest priority here, X-ray diffraction. Now, we have better access to a scanning electron microscope, so that might happen first. But the one that I keep screaming from the rooftops we need to do is the X-ray diffraction, because that'll show us if indeed those bismuth-colored spheres or whatever shape they are, if indeed they have a regular lattice structure or even an aperiodic lattice structure like quasicrystals. Another thing that's been suggested is something called radon transform. Don't ask me what that is because I don't know, but another one of the scientists from the group said, hey, we should do this. It's non-destructive. You can tell us some stuff. So we're possibly going to do that. The main goal with this sample, though, is Mark is going to be testing the sample in his Alzaphon experiment, which is dynamic nuclear polarization, where you put a special sample into a RF cavity that has a specific magnetic gradient applied to it, and at certain magnetic gradients, at certain RF pulses, the thing will lose weight. It's a super awesome idea for anti-gravity. All right, now I got some notes. So despite the fact that there's very low lead in it, some kind of better control process seems extremely likely, because there's other trace elements, and in Art's parts, it's got some calcium in it as well. That's screaming some kind of better control something. Oh, whoops. Sorry about that. There we go. So I'm not going to say that aliens are off the table. Maybe the aliens are using better control, but that really feels like you're reaching at that point. It was also totally possible for the methods that were available at the time for this to have been made terrestrially. That's something that a lot of folks don't realize, myself included, that material science was actually pretty impressive back in the 40s and 30s and 20s. So these colored microspheres, like I keep saying, they could be totally prosaic. They could just be an artifact of heating. They could be a whole bunch of things. But the irregularity of the colors, combined with the arrangements and circles and lines and stuff, I don't know, it's piquing my interest. I'm keeping my fingers crossed, my hopes high and my expectations low that we'll find some quasi-crystal stuff going on with that, because that would be super cool and would be total evidence that this thing was not made by people, because quasi-crystals weren't even a thing until the 80s. They weren't even really making them until much later after that. Also, as an aside, there's been some alien implants that have been analyzed with similar scrutiny that have also shown some similarities to this with chemical makeup, isotopic makeup, and nanostructures that are present. So for all that's worth. Something that's interesting about that is you couldn't find anything where anyone who done any tests on Art's parts ever mentioned anything about hexagonal structuring. And on the larger samples, you don't really see that hexagonal structuring much. So maybe that's why. It could just be an artifact. Maybe that hexagonal structuring is like nothing to do with anything, and it just so happens the piece we have is small enough that like you see what you want to see, and the 6 or 7 little hexagon things we see on there is totally arbitrary. Who knows? But if not, that could be a new discovery. It's important to note that magnesium and zinc, each of those individually have hexagonal crystal structures, but when you combine the two, you get icosahedral structure. By the way, in case this thing does have quasi-crystal nature to it, that magnesium zinc would indicate icosahedral symmetries, which are important for quasi-crystals, and I'll go into that a little bit later, but just keep that in your back pocket. All right, let's talk about some thermoelectric generation. This is how you convert heat into electricity. Well, bismuth magnesium and bismuth zinc, there's a lot of research out there on how you can use those to create electricity from heat. Those radiator fins that we saw at the beginning, maybe whoever made this thing was using heat somehow to create electricity, but they needed a way to create a thermal gradient, so that's the fins. The iridium angle that Linda mentions, she was at some conference talking about the thing, and after the conference, some guy comes up to her and says, hey, I'm from S4, here's my credentials. She was convinced of his credentials. He claimed to work on a 3-foot by 6-foot section of the hull of this same craft. And he said what was special about it was that the aluminum outer hull had atomically placed iridium in it, and it was the combination of those two things working together that actually made the thing able to lift. For radioactive thermal generators, like those used in satellites, they also use some heat fins, and they also have iridium present in them. So maybe there's some kind of there. So the 1947 UFO, that glowed for 3 hours after it crashed. The White House 1952 one glowed for 1 hour. Well, in the mid-50s, the Norwegian Air Force observed a bunch of UFOs coming and landing and taking off on the ice sheets. And like this Air Force general said, yeah, it seems like the intensity or the luminosity of the light coming off these things is directly related to how fast they're taking off or how fast they're decelerating. So that's interesting. I think that might indicate that there may be some relationship to the amount of light coming off of these things to lift, but not necessarily, solely that's what's responsible for it, because, these things kept glowing for a couple hours, but they weren't lifting. So, who knows? So there could be thermoelectric properties of the bismuth. Since we're talking about light, there might be thermoluminescence at play. The magnesium ions and the zinc seems like there might be electrical at play, because those are kind of used in some battery applications together. So Canada was their inside group was inspecting an electrogravitic model, but after the 1952 flap, when they got that sample, they stopped looking at the electrogravitic and they started looking at the gravitomagnetic. They abandoned the charge for the magnetic side of things. So that's an interesting side note. Colonel Corso, who wrote the book Day After Roswell, right? He said that the entire vehicle functioned like a giant capacitor, somewhat similar to what the alien reproduction vehicle, the ARV from McCandlish, kind of like that angle. Anyways, he says the entire vehicle functioned like a giant capacitor. The whole craft stored a bunch of energy, and somehow it used that energy to propagate a magnetic wave that let the thing defy gravity. And yeah, some crazy stuff going on there. All right, here's speculation what other people have been saying about this. They've been saying that since bismuth is so diamagnetic, that it might have been used as magnetic shielding. Actually, that's what one of the original source, the grandfather who originally got the sample, that's what he said in his diary, was that he had spent 6 weeks with the recovered alien and the recovered craft after the fact. This is one of the things that he relayed, was that bismuth was being used to repel external magnetic fields. It's important to note that diamagnetism, negative susceptibility, bismuth has the highest negative susceptibility, meaning it expels the most magnetic fields short of going into superconducting territory. Sarbacher, once again, he claimed that had bismuth nanospheres of 10 microns. Here's that MUFON case for you. If you have a MUFON, $5 a month registration, you can go look up this case number and see what somebody wrote about that. Sarbacher was talking to Stanton Friedman in 1983 and started talking about bismuth's gravitational irregularities. Coincidentally or synchronistically enough, just 2 hours before I found that out, I found out about those gravitational irregularities from a different paper. So I saw this thing about Stanton Friedman and Sarbacher. I'm like, wait a minute, I know exactly what it was Sarbacher was referring to. It was called the brush kinetic theory. And this was some scientist back in the late teens and early 20s, 19 teens and 1920s. He was doing these pendulum tests with 5 different kinds of metals, like iron and aluminum and zinc and bismuth. He was doing all these different, really good pendulum tests. And he was noting, do all of the different metals, when you account for all the variables, do they all swing at the same period? Or do any of them, change, how fast they swing, indicating they have a different relationship to gravity? And he put zinc as his control sample. So he says, okay, this one is the most perfect gravitational one. Aluminum was way faster. It oscillated way faster than zinc. And then bismuth swung way slower than zinc. And so it seems like this guy 100 years ago figured out that bismuth doesn't obey gravity all that well. And he reproduced the test in 1922 or 23 instead of just doing pendulums. I think he was doing drop tests or other momentum tests. And he, once again, validated his original experiment. Quite interesting. Let's get into some of my more favorite out there stuff about quasi-crystals, because these are the things that have just captivated me for the majority of the time that I've been researching this. So it turns out that the Trinity nuclear test back in 1945, that created quasi-crystals from the nuclear explosion. What? we didn't know about that until like, 2010 or 2020 or something, when somebody went back out there and knew to look for them. But yeah, the earliest human created quasicrystals that we can find came from the nuclear tests, which seemed to attract attention of all the aliens or all the flying saucers. So, just put that in your back pocket. Quasicrystals have this really cool thing about non-locality because they're a non-normal crystal. They're not like a cubic, three-dimensional cube crystal. They're like aperiodic like this. That means that when you push or you dislocate one cell of those, it actually has like downstream effects on the other side of the crystal. It can like do action at a distance type stuff. Super interesting applications there. Information processing, whole field. Like I could have a whole talk just on the information processing side of quasicrystals. Oh my God, that's amazing and could completely revolutionize literally everything. I'm getting a little too excited about that one, but like so much on the information processing. So instead of phonons, which are like oscillations in a normal lattice, or like sound waves or mechanical waves, that's a phonon. Well, when you're operating with a weird lattice like a quasicrystal, it's called a phason instead of a phonon. Who cares what you call it? But the cool thing is that you can have this coupling between those two things, because when you look at quasicrystals in higher dimensions, you end up seeing a whole bunch of normality to this crystal, but you slice it down and you go into our dimension, and now it looks all wonky like this, right? Well, there's ways that you can make coherent phonons from quasicrystals, which if you can make coherent phonons and you can couple those to the phasons in the quasicrystal, there might be a whole other angle of alternative propulsion just waiting to be devised from this phonon, coherent phonon coupling stuff. Obviously, I don't know nearly enough about this to talk intelligently about it, but that will probably eventually come. I would love to do a presentation at some point just about quasicrystals. I know Jeremy Reese has already done a good amount of work. So has David Chester. They've done a lot of work on quasicrystals. So I would reference you to them far before myself. Anyways, there was a Russian meteorite. So the only other naturally occurring quasicrystal that has been found came from a Russian meteorite back in like the early 2000s. And that thing had icosahedral symmetry to it, which is interesting because magnesium zinc of the arts parts would mean that it must also have fivefold symmetry, icosahedral symmetry, if it does have quasicrystal nature to it. So the information processing, one last thing on the information processing, these new computational methods that you could devise from that, like just jumping right into the deep end of the Kool-Aid pool, like you can describe certain different kinds of consciousness. You can describe plant consciousness as well as human consciousness, all the microtubule stuff. You can describe that using quasicrystals. So it's interesting to start looking at the overlaps between information processing using quasicrystals and consciousness using quasicrystals, as well as maybe some higher dimensional information processing that the universe might be operating upon if the universe is computational in nature. All right, we're just about done here. So here's what we still need. This is what I would suggest that anyone else that's really interested and wants to spend some time looking into this, here's what I would suggest. Can anybody find a special use case for this bismuth, magnesium, zinc? Can you find a paper that was written prior to 1947 that talks about these three things being used together? Because that would be really interesting. Especially if it was with regards to some kind of thermoelectric, thermoluminescent models. Here's a little something that most folks don't know. So I am okay at being able to track down people from time to time, and I started trying to track down this original grandson source. Here's what I was able to find. He was from South Carolina. He was going to South Carolina to mail these letters off. And in the letters, he says, like, I actually live in Virginia, but I take these military hops out of Pope Air Force Base in North Carolina down to South Carolina, which is why all these letters are postmarked from South Carolina. After the last letter, he called Linda up on the phone. This is the only time Linda ever talked to him. He mentioned, Linda says this in one of her things, he mentioned that he was going over to Iraq in 1996, later summer of 1996. So he wasn't able to talk long, but that was like the last correspondence he was going to have with them. Well, I did the digging, and sure enough, the South Carolina Air National Guard went over there. Also, that C-130 pilot friend that he had suggests he might be C-130 crew. The weird thing is he uses some words that suggest this guy is not a pilot. He claims to be like a commissioned officer of some kind, but if you really wanted to like inflate your title, you could say you're a non-commissioned officer as a commissioned officer. So he might have just been a striper rather than a brasser. And some of the words he uses makes me think he might have worked in logistics. I was picking the brain of another veteran who was a veteran in the Air Force from that time. And I read all the letters out to him, and he's like, yeah, no, this guy is not a pilot. This guy's probably not even air crew. He might have gotten his wings from like being active duty and then palace chasing over to the National Guard. But this guy talks like a logistics guy. So interesting. I think that with enough gumption and like 1 or 2 FOIA requests, it'd be pretty easy to figure out who this guy was, which would be good because then we might be able to track down the journal, hopefully, whether or not this guy's even still alive. But we might be able to track down the journal from the grandfather, which would be huge. There's a lot of stuff in there that we didn't know about. Yeah, that would be interesting. Anyways, RTG and TEG research prior to 1950. And then anybody that wants to look into how quasicrystals can be related to thrust, highly encourage that as well. Here's the last slide I got for you before the bibliography. Right now, as it stands, this is my analysis of it, combined with the analysis of a bunch of other material scientists I've talked to. This thing seems like it was made terrestrially. And it could have been made prior to 1947. That said, the materials here, it looks like it could be used for thermoelectric type stuff. And if this thing has quasicrystal structure in it, that is the smoking gun that this thing is like either not human made or was made by somebody that knew a lot more than anybody else at the time for the next like half a century. Here we go. So here's the bibliography. Anybody that wants to check this out, here's the long address for it. I got the short address, which is a tiny URL, parts Falcon Space. Here's the Linda Moulton Howe interviews. I highly recommend checking those out, especially this first one, because Travis Taylor tested this thing way back when, and he tested the sample at 500,000 volts and 1.2 million volts. He got the thing to kind of dance around, whatever that's worth. It was a little bit hokey, I thought, but you know, it is what it is. He did a good test on it. We got more links. Highly recommend going through whichever one of these seems interesting to you. I think they were all interesting, but the Ubatuba, that white paper, if you're interested in learning more about like the process that should be done for going through and testing recovered materials, that paper goes into great detail. Also this book, you don't have to read the whole thing, but I highly recommend at least reading pages 43 to 50. That'll teach you a lot about what I was saying with the White House flap and the Norwegian Air Force. Highly recommend that. Going down here, here's a paper, like 8-10 page paper that some material scientists shared with me that kind of helped give me an idea on the fact that this was indeed a process that was possible. There's some phase diagrams for magnesium bismuth. Here's an extremely recent paper on how this stuff might actually be used for thermoelectrics. Highly recommend everybody checking out Tim Venture's shared pictures of the samples that we took. I did a Reddit post this week talking a lot more about the quasicrystalline stuff of this. Jeremy Reese did some good quasicrystal research. And then I got this working document that is messy as all get out, but I had to cut out a ton of stuff. As you can see, I'm running out of time. This working research document, if you're interested in learning a bunch more that I didn't share, I suggest following that link and torturing yourself by trying to make sense of the disorganized, semi-organized pattern that I got for that research doc. That's all I got.